rain simulation in the lab. We're also going to use a thinking routine to help understanding, similar to that used by Project Zero, and you might like to look at some of the other Project Zero strategies. And we're going to produce one of the materials that contributes to acid rain in the lab. We're going to use a universal indicator to monitor the change in pH. And remember, we're going to use normal lab safety precautions, goggles, lab coats. We've got concentrated acid, so need to be particularly careful with that. The acid rain simulation produces a toxic gas, so we'll need a fume hood for both setup and cleanup, and students 3 meters away. And you can pause on this slide to make sure you've got all the materials that you need for the reaction to take place. I'm going to use copper turnings and put it in the center well of a well plate. And then we're going to use a dropper to put 6 half to 1 mil portions of universal indicator in the corners and the ones adjacent to the copper turnings. And going to carefully place the well plate with its contents in a zip sealable baggie, and then carefully add about 1 milliliter of 8 molar nitric acid in the center well with the copper turnings. And then again carefully seal the bag completely. That's your reaction vessel. And you're going to observe during a 5-minute period and complete the thinking routine with your observations throughout the activity. So let's read the thinking routine instructions. And so what do you see here? You won't smell much because it's in a fume hood. And what did you see that made you curious? Think about what's going on, explain what you see, and what can't you explain, what's going to be hard, and what you wonder about as you see this, what would you investigate further? So here's a summary of the procedure, so you can pause that and look, and here's a summary of the thinking routines, the see, the think, and the wonder. And then writing down your observations as you see the activity, and keep looking and looking closely at what's happening. Now you're going to watch the lab or the activity. Here are the results of the lab. What can you see? What has been happening? The reaction in the center well plate. Got a description here and the equation and what the colors are. And again, the color changes of the universal indicator solution and what that means. So we need to explain that in the bag we are simulating dry deposition. Factories, vehicle exhaust produce NO2, but we've got the chemical reaction in the baggie. And all rain is acidic, pH below 7, but not all is described as acid rain. The pH has dropped to close to 4 and caused by factory emissions, sulfur dioxide, but also nitrogen dioxides, and burning fossil fuels does this as well as vehicle emissions. So the pollutants are transported a long way from the factory in the air, in clouds, by the wind, and they're leaving the vehicles and the factory exhausts. And you can have dry deposition where it's not raining and wet deposition where it is, and they're going to damage wildlife and affect rivers and lakes. So in LA in particular, Los Angeles sits in a basin with surrounding hills and high temperature in car engines produces sulfur dioxide, and burning fossil fuels produces the SO2. And pause here to get the equations of the reactions, including from lightning and sulfur dioxide, also from volcanoes. And we've got wet deposition and dry deposition. From the wet, from rain, snow, fog, and hail, and dry deposition, where the acidic particles and gases deposit directly to surfaces. And here you can look at sulfur and nitrogen deposition from 2017 values and the regions where it is highest, and the low regions as well. So many thanks to Washington International School and Team Science, and in particular Miss Hager's 12th grade chemistry class.